All right, so we plugged in 2 and -2. We'll see what works out. So 2 cubed, 2 times 2 times 2 is 8. 2 squared, 2 times 2 is 4. 2 times 4 is 8. 8 plus 8, 16, plus 1 is 17. Now the other side. -2 cubed. Since it's an odd exponent, we know it's going to be negative. 2 cubed is 8. -2 squared, since it's even exponent, that'll make it positive inside the parentheses. So 2 squared is 4. They're both positive. Positive, positive is positive. 2 times 4 is 8.
1.
Those cancel, so it's 1. So since they're not equal, this equation is neither even nor odd. It's neither. So that's what we're looking at for symmetry, is if I change the x values from positive to negative, will it change the y values? If it remains positive, if I have a function and it gives me the same answer as if I put the negative x in there, we call that an even function. If I have a function and I put a negative number in there, and it just makes the same number of different signs, we call that an odd function. All right, so that's symmetry. Now, with what I started off talking about here for symmetry, you have a point. If it's across the x-axis, what changes? Only x's change. And they only change their sign. So I start off with 2, 1 here. That's my original point. If I flip it across the y-axis, the x changes sign. Because if I go this way, the only thing changes are the x values. The y stays the same. And that's called an even function. If I start off with a point 2, 1, and I flip it across the x-axis, it's a vertical reflection, then only y values change. It's not even the y values, it's the sign of y and the sign of x. And if it's across the origin, both x and y change signs. All right, that's symmetry. All right, so what we're looking at is what the graph's going to look like. Okay, now let me give you a picture, and you tell me if it's symmetric about the x-axis or the y-axis or neither. Okay, let's look at the top three. The first one, let me ask you, is it a function? No, because it fails the vertical line test. Is it odd? What does odd mean? Odd means it flips across the origin. There's this point and that point. It's supposed to be a circle. This is an odd function because this point here has a mirror image over here. This point here has a mirror image there. Every point has a mirror image. So I flip down and over. So it's an odd function. An odd function means it flips both X and Y axis. Because it has to flip down and it has to flip over. Or it can flip over and then flip down. So that's what an odd function is. How about the second one, the y equals x squared, the parabola? Is that symmetric about anything? The x-axis? The y, yes. This is symmetric about the y-axis. So is it odd or even? This isn't even, right? Because the only thing that changes are the x values. The y values stay the same. The third graph is a graph of the absolute value function. Is this symmetric about anything? Yeah, it's symmetric about the y-axis again. Because if this is 1, then this has to be -1. So it's an even function. Because it flips across the y-axis. All right, the next one. A diagonal line. Neither. Remember, okay, to be odd, what does it need?
Negative and positive results.
Right, it has to have a flip on the x-axis and a flip on the y-axis. Or flip across the y-axis and down. So if it's symmetric about the origin, then it's odd. Is that line symmetric?
Yes.
No.
Oh.
It's a trick question. Because is it across, this one goes through the origin.
Right.
Does this one?
No.
So it can't be symmetric about the origin.
Oh.
Because if it was symmetric about the origin, these points would have points over here. So this example is odd. This is neither. And this last one, hyperbola. Is it symmetric?
Not a function.
It's not a function. It's neither.
Mhm.
But it is symmetric about the x-axis. Because for any one x you give me, I have two values of y. Let's talk about functions. Let's talk about the library, because how many of y'all have seen any of these functions before? Okay. Let's look at the library of functions. And I'll give you that sheet next week. So let's. So we're just gonna draw 8 or 10 spaces. We'll call this the library of functions. The first function is called a constant function. For example, f of x equals 3. It's a constant, it doesn't change. So that graph will be a horizontal line. The domain has to do with the x-axis and the range with the y-axis. What's my domain here? All real number, yeah. Negative infinity, positive, very good. So, or you could just put the all real number symbol. Either or. Because I can use negative x's, I can use 0, I can use positive x's. So I can use all the x's. So my domain are all real numbers. The range, it's only whatever the constant number is. Whatever the constant number is, it's a horizontal line. This one's called a linear equation. It's a linear equation because the graph's going to be a line. How do I know it's a linear equation? There's no special operations around it. There's no exponent. X is not on the bottom of a fraction. So the graph of this, when x is 1, y is 1. When x is -1, y is -1. And so on and so forth. It's a 45-degree angle line. The domain of this one is what? What are my possible x values? All real
The
numbers.
same, negative, infinity.
Mm-hmm. Yeah, because I can use any negative number or any positive numbers. It's and 0. How about the range?
It changes, so it would
No,
be,
because think of it this
No.
way. If I use negative infinity here, it's going to go to negative infinity. If I use positive 100, it's going to be 100. So it's going to be the same thing.
Oh,
Because this arrow and this line tells you it goes on forever and ever. It matches all the y values, it matches all the x values, so it goes on forever. So it's all real numbers. Next one, f of x equals x squared. This is called a quadratic equation. It's called a quadratic because it has a power 2. the graph of a quadratic equation is the U. It only touches the x-axis at 0. It's called the vertex. The lowest point is called the vertex. The domain of this function all real numbers. Basically, to answer your question there is, are there any restrictions that I could put in there? Can x be negative? Can x be positive? Can x be 0? If you could put anything in there, it's all real numbers. How about the range? What are the possible y values?
All real numbers?
And I can't be negative. So the
Oh,
smallest it could be is 0, and it can go up from there. So y is greater than or equal to 0. Or I could put the interval notation 0, infinity. Okay, now this is called a cubic. F of x equals x cubed. It's called a cubic. Basically, the difference between a cubic and a quadratic is whenever you have an even exponent, it'll make any number positive. That's under it. -2 times -2 is +4. But if I have an odd exponent, if I put a negative number in there, the answer is going to be negative. If I put a positive, it'll stay positive. So basically, I just took this left side and cranked it down. That's what that looks like. And we're going to look at another set of equations like that. We'll talk about those in a second. The fifth equation, the square root of x. We haven't done domain range. Yeah, both of these are all real numbers because it goes on forever both directions. Okay, this is called a square root function. Square root radical. What are the rules about square roots? Can you take a square root of a negative number? No, because whatever number's inside there, you have to be able to multiply the same number twice to get that number. Like square root of 4 is 2 because 2 times 2 is 4. Square root of 16 is 4 plus 4 times 4 is 16. But if I had square root of -9, -3 times -3 is a +9. So you can't have negatives. So no negatives. Can it be 0? Square root of 0 is 0. And it can be positive. So since it can't be negative, it could be 0. Square root of 1 is what? 1. Square root of 4. There's a dot there. Square root of 9
3.
is 3. So you see how far it goes out before it goes up one? This is a very slight curve.
Mm.
But it cannot be negative. And the answer cannot be negative. So what's the domain?
Zero.
X is greater than equal to 0. Or 0 to infinity. And the range, the lowest it can go is 0, and then it goes up. So y is greater than equal to 0, or 0 to infinity. The next one is called a cube root. Radical. Now, in a square root, there's an invisible 2 here. That's why you need 2 of a kind. In this one, you need 3 of a kind to take it out of the radical. So since it's an odd root, our answers can be positive, negatives, and 0. So there's a graph. The domain and the range are the same. It's all real numbers. So far, so good. Because I'm going to ask you all to memorize these symbols, these functions, because the faster you memorize them, the easier the rest of this course is going to be. All right. Now, those are the radicals. Now let's look at the rationals. 1 over x. It's called a rational equation. Now, do we have any restrictions on x here? Can x be negative? One over -1 is -1. So the bottom can be negative. Can it be 0? No. So we cannot use 0. So x in this case cannot equal 0. We have restrictions. Anytime you have x on the bottom, you have a restriction because the bottom can never equal 0. And we call that an asymptote. An asymptote is simply a vertical line that the graph cannot cross because it'll make the denominator 0. A vertical asymptote. If x is 0, it's undefined. We can't use that. So basically, the bigger the bottom number becomes, what happens to the overall number? Bigger x gets, what happens to the number 1 over x? It gets smaller and smaller and smaller. So that means the closer it gets to 0, it gets bigger. And the farther it gets from 0, it goes to 0. It goes very close to 0. Likewise, in the negative realm. but it stays in the negative quadrant. What's my domain? To where? To 0. Yeah, you can say that just x cannot equal 0. Or if you want to do that, you can go negative infinity to 0, union 0 to positive infinity. You could do that. Or you say that x cannot equal 0. Now, can 1 over x ever equal 0? How can a fraction equal 0? The only way a fraction can equal 0 is if the top is 0. Can the top ever become 0 if it's 1 over x? No. So it'll never equal 0. So y can never equal 0. So that's it for that one. Rational squared. So what can you tell me about this graph by looking at the equation? Do we have any asymptotes? Remember, the asymptote is what are the x values that make the bottom number equal 0? So if x is 0, the bottom 0, you can't have that. So x cannot equal 0. That's your asymptote, your vertical asymptote. So since x cannot equal 0, again, same thing here. When x gets bigger, the number gets smaller. So on the positive side, it looks like that. It just grows a lot faster. How about the negative side? If we put a negative in there and square it, what happens to it? It'll be positive. Yeah, so this side of the graph looks like this. Kind of looks like the Atari symbol. Again, it'll never cross the y-axis because the top can never equal 0. What's the domain?
Negative infinity to 0, union
Yes,
0
yes.
to negative to infinity.
Very good. Or x just can't equal 0. Right. Both of them work. Very good. How about the range? Very good.
Infinity to
Y is greater than 0, or parenthesis 0 to infinity. How about the absolute value of X? So what does the absolute value tell us? The absolute
Total is
value,
positive.
it's always in positive. Yeah, it tells us the distance between two things, between a number and zero. So the absolute value tells us the distance a number is from zero. And that's a positive number because there is no negative or positive distance. It's just a length. Can you put negatives inside there?
No.
Yeah, you can. Absolute value of -3 is 3.
3.
So you can put negative numbers inside there.
Mm.
Can you put 0 inside there? Yeah. And you can put positive numbers inside there. Absolute value of 3 is 3. It just, what it does, it takes whatever number, not an equation, but number, and makes it just positive inside there. So when X is 0, Y is 0. When X is 1, Y is 1. When X is 2, Y is 2. When X is -1, Y is 1. When X is -2, Y is 2. So you have two linear equations there. How about the domain and range? What's my domain? Can I use negative numbers? Yes.
Yes.
Can I use 0?
No.
It's part of the graph.
Oh, yeah.
Absolute value of 0 is 0. Can I use positives? Yeah. So this is all real
Yes.
numbers for the domain. Negative infinity, positive infinity. How about the range? Very good. Y is greater than or equal to 0. That's as low as it can go. Or bracket 0, infinity. And the last one we're going to talk about, because the other two we're going to talk about later on in chapter 6, exponentials and logarithmic. This is called the greatest integer function. The greatest integer function. In other words, what it means, it truncates the negative values. I mean, the decimals, not negatives. It truncates the negative, the decimal values. So you always have just a number that's in front. So for example, when X is 0, the equation is 0. If I had 0.1 and I get rid of the decimal, I get 0. If I get 0.9, I get 0 because I drop the decimals. At 1.0, what happens? it becomes 1. So it stops at 1 and jumps up to 1. So it goes all the way to 2 and it jumps to 2. And so on and so forth. And likewise on the other side, on the negative side, negative 0.3 drops to 0.3, so it's negative 0, all the way to 1. At 1, it drops down, all the way to 2, then it drops down. What does that look like? This is called the stair step function. It looks a bunch of steps. It's called a stair step function. The domain, can you guess what the domain is going to be? Very good. It will be all real numbers. Because you never have an open space. When it goes to -1, it jumps from -1 or -2, -1. And so on and so forth. So you never have any openings. How about the range? That Z stands for integers. The range are only the integers from negative infinity to positive infinities, no decimals. And that's what that Z stands for. So this is the library of functions. Well, until we do logarithms and exponents. But almost every equation you'll ever see starts off with one of these. The sooner we can memorize these, the better, easier everything else will be. Oh, everybody okay with this? I'm gonna want you guys eventually to get to a point no matter what kind of equation I gives you, you can tell me the basic shape of it. You can tell me the shape of it by only looking at the beginning and the last terms, the first and last terms. The number at the back is called the constant. It doesn't have a variable letter X. So what's the constant always going to represent?
The y-axis?
The y-intercept, yes. It's the y-intercept. So we know already in this first graph, it's going to cross through 1 on the y-axis. It's a lot more we knew than 5 minutes ago.
It's a quadratic.
What's that?
Quadratic?
The first one's a quadratic. Yes, we know it's quadratic because there's a 2. Now, okay, I said that. Because it's a quadratic, it tells us a whole series, a whole story. But this first one, we call this the leading term. The leading term gives us a lot of information about the graph. So this whole thing is called the leading term. The 2 is called the leading coefficient. The square, the power, tells us it's called a degree. So let's only look at the leading term. Let's see what it tells us and how we interpret it. The leading term, so it's a 2x squared here and the x cubed there. The leading coefficient is a. It's whatever is in front of the x is my leading coefficient. This tells us the direction and the vertical shape of the graph. Basically, is it going to be tall or short? If it's tall, it's going to be spread out. If it's short, it's going to be scrunched. The degree n the degree tells us a lot more. Number of possible solutions. Number of x-intercepts. Or a possible number of x-intercepts. The shape of the curve. And it tells us what happens at both ends of the graph. That is called end behavior. The degree n, number of possible solutions, possible numbers of x-intercepts, the shape of the curve, and what happens at both ends. it can all be narrowed down into this little picture right here. Here, n is even, n is odd, a is positive, a is negative. All right. We're going to get the n behavior. So if a is positive and n is even, what that's telling us is that both ends will point up. We don't know what happens in the middle just yet. If the degree is odd and a's leading term is positive, both ends point different directions. Again, we don't know what happens in the middle. If a is negative and n is even, both ends will point down. We don't know what happens in the middle. If a is negative and n is odd, the left side points up and the right side points down. All right, so that's one thing. This tells us the end behavior, what the basic shape of the curve is going to be. So with that, let's look at the first example. So what can you tell me that graph's going to look like? Approximately. We know it crosses the y-axis at 1. Since it's an even degree, that means both ends point the same direction.
Up.
They're both, why are they up? Because this number here is positive.
It's bigger, yeah, it's positive.
It's greater than 0. So let's see here. Now, is it going to be on this side or is it going to be on this side? Let's see. Let's plug in a value 1. So 2 minus 3 is negative 1. So it's right here. So it'll look something like this. Because if I put 1 inside the equation, 2 minus 3 plus 1 equals 0. So the graph will look something like this. It'll look something like this. Okay, how about the next one we had up there? What do we know about that one?
That's an odd positive number for the leading term.
Right, okay. So we know the leading term. It has a 1 here, 1's greater than 0. And it's an odd degree. So what does that tell me?
That's bigger than 0.
Right, it's 1's bigger than 0.
And it's pointing in different directions.
Yep, because of this, it's pointing in different directions. Since the leading term is positive, we know that this side goes down and this side goes up.
And the y-intercept is 3.
Very good. The graph
Curve.
can look something like this. Why do I think it looks something like that? Is because the degree tells us the maximum number of x-intercepts. X-intercepts are also called solutions. So since the degree is 3, it's telling me I can have at most 3 x-intercepts. The number of vertices. What is a vertex? What is a vertice? What's a vertex? It's the highest or lowest point on a curve. You're not gonna, when you're on a roller coaster, the point where the roller coaster doesn't move, doesn't go up or down. Those are the vertices. Those are the vertices. So the number of vertices will always be, well, usually be 1 less than a degree, or 1 less than the number of solutions. The number of vertices will always be 1 less than the number of solutions. It's typically the number of the degrees of -1. So again, the degree is the exponent. It tells us the maximum number of x-intercepts. Those are also called solutions. And the number of vertices we're going to have is 1 less than the degree. And that's exactly what we have here. Since the second equation was a cubic function, we have 3 solutions. If we have 3 solutions, then we have 2 vertices. Likewise in the first one, the degree is 2. So we'll have 2 solutions and only 1 vertex. 2 minus 1. Why do I say maximum number of solutions or intercepts? So the degree n equals the maximum number of solutions possible. So let's look at the basic one. When x equals 1 or n equals 1, what kind of equation is that? Remember, this is your degree.
The same value of x.
Yep. It's a value of x. So it's a straight line. Remember, the degree tells us the number of intercepts we can have. There's one solution, one x-intercept. And 1 minus 1 is 0, so it has no vertices. If n equals 2, then there are 3 possibilities. Because it says that we're going to have at most 2 solutions, and we're going to have 1 vertex. Because it's 2 minus 1. So let's look at this. The graph can look like this, and like this. So how many solutions are here in this first picture? 2 solutions. And the next one?
1.
Only 1. And the last one? No solutions. Let's look at the next one. Let's look at n equals 3. Y equals x cubed. We have 3 possibilities. Those are our 3 possibilities. Because n is 3, the degree is 3, I can have at most 3 solutions, which means I have 2 vertices. Or I can have 2 solutions, or I can have 1 solution. I can't go any further than that. So what do we notice about the odd and even degrees and number of solutions? If the degree is even, at most, you can have n number of solutions. Or you can go down to 0 solutions. This is if it's even. Now, When I say zero solutions, it doesn't mean you won't get any answers. What it means, you'll have no real solutions. You will have answers, but they'll be imaginary. You're gonna have numbers that are really weird, which we'll get to next chapter. So if the degree is even, you can have at most n all the way down to zero solutions. If it's odd, at most you can have n solutions. But you have to have at least how many?
3. Oh,
One.
sorry. At least.
At least one, yeah. You must have at least one solution. Why? Why is it one solution?
Well, the line has to cross the x-axis at one point, at least one point.
Why?
Oh,
It has to, but why? Think of the end behavior. The end behavior of even degrees is they either both point up or they both point down. They both point the same direction.
Right.
So if the x-axis is below that, they'll never touch. That's why you have 0. But odd degrees, the end behavior, they point different directions. So one of those sides has to at least cross the x-axis once. And you can have a function that looks like this. But it has to have one x. If it's an odd degree, it has to have one x-intercept, because both ends point different directions. So far, so good. Let me give you one. Just rough sketch what this graph may look like. The only thing we know for sure is what?
The y-axis, the 6.
Why? Yeah, the y-intercept. That's the only thing we know for sure. There's another thing we do know for sure.
Well, the term is even number, the primary term.
Yeah, the degree is even.
The leading term.
Well, the leading term of, yeah, that's the leading term. This is the leading coefficient.
Mhm.
It doesn't matter if that's odd or even, doesn't matter that. It just
Yeah.
matters that it's positive. The leading term, or the leading coefficient is positive and it's even, so what does that mean?
You have the sketch going up above the x-axis.
Yeah, both ends will point up. Because since the degree is even, we know point the same directions. since the coefficient is positive, it points up. If it was negative, it would point down below the x-axis. At most, how many x-intercepts? Six. The degree tells you how many x-intercepts. So let's say there's an x-intercept there, there. So we can have a graph like this. But the only thing we know for sure are the end, how they look, and the y-intercept. Believe it or not, in chapter 4, you're going to solve this equation. You're going to tell me all the x-intercepts, whether they're imaginary, whether they're real. You're going to tell me how many vertices we're going to have. So pretty cool. So that's what we're going to do now. All right, so that's what we have to do about what the important parts of a function are. We talked a little bit about symmetry earlier in the beginning of class. Symmetry simply means the mirror image. About the y-axis, about the x-axis, and about the origin. When I say about the, I'm saying if they're saying I'm flipping across the y-axis, flipping across the x-axis, flipping across the origin. So earlier I had the point 2, 1. That's my original point. It's at 2, 1. If I flip it across the y-axis, what's the mirror image? What's the mirror point across the y-axis? Here's
1
the
to -2.
Yeah, it'll be -2, 1. Because when you flip across the y-axis, change the sign of x. That's all it tells me. If it's moving horizontally, that's across the y-axis. So that's that one. Only thing changes are the x values. If I flip across the x-axis, what changes? Does the sign of x change? Yeah, here you change the sign of y. So it would be 2, -1. And across the origin, that's you change both. So it'd be -2, -1. Because what across the origin actually does is you flip across the X, then the Y, or you flip across the Y, then the X. In other words, you negate both of those. All right. And as we talked about earlier, we have odd and even functions. An even function flips across the y-axis. An odd function flips across both x and y. Any questions so far? Let's look at, there's a shortcut. Because if you're asked, is the function odd, even, or neither? Let's look at these. The first one. F of x equals x squared. Is that odd, even, or neither? The way you test it, if you put a negative value in, if you put a positive value and a negative value in there, and they both equal, then it's even. No, it means nothing changes. If you put a negative value inside there and it turns out you have the same numbers but different signs, then it's odd. Anything else is neither. So let's look at this. Here's x equals 2, x equals -2. So that's the way I test it. I have to have the same number but different signs. Whenever you substitute something, always put it inside parentheses. 2 squared is 4. -2 times -2 is +4. Since those are equal, this is an even function. How about x cubed? Is it odd, even, or neither? First thing you have to do is just pick a number and plug it in there, see what happens. Positive and negative, that number. And just plug it in place of x inside the function. Two cubed, 2 times 2 times 2 is 8. -2, -2, -2. Since I have odd number of negatives, it's negative. 2, 4, 8. The answer is -8. So what does that tell us? It's odd because I have the same number. They're both eights. One's positive, one's negative, so it's odd. How about a constant function? Is it odd, even, or neither?
Neither.
Ooh, what, how did you test that answer?
Because it doesn't have, well, it's constant because it doesn't, it's not gonna go through the x-axis.
Well, okay, so let's see. Let's say we pick a value for x. Let's say 2 and -2 again.
Okay.
If I put negative or 2 in there, what happens? Does this number change? No.
No.
I put -2 in there. Does it change? No. So they're equal. Even though I put positive and negative numbers in there, it's equal. So this is an even number. Even function.
Oh, okay.
Because if you think about it, the graph is a horizontal line. It flips across the y-axis. That's why it's even. If it flips across the y-axis, if it's a mirror image across the y-axis, then it's even. That was a trick question. We have 3 more to test. How about that one? Right, so we do the same test. X equals 2. X equals -2. So we have 2 squared plus 3. -2
Even?
squared. Yes. So -2 squared is 4. 7 equals 7. So it's even. Very good. All right, look at the next one. This is number 5. F of x equals x cubed plus 3. Yeah, you can pick whatever number you want. I just like 2 for some reason. So 2 cubed, 2 times 2 times 2 is 8. 8 plus 3 is 11. -2 cubed, since it's an odd number, the answer would be negative. Negative, negative, negative makes it negative. 2 cubed is 8. Plus 3, 8's bigger, it's negative. 8 minus 3 is 5. Since 11 doesn't equal -5, or they're not opposite sides, it's neither. All right, how about this next one? X cubed plus x squared.
It's neither again.
Well, it's 2 cubed is 8. 2 squared is 4. It's 12. Negative 2 cubed is negative 8. Negative 2 squared is positive 4. 8 is bigger than 4, so it's negative 4. So it's neither. Okay. Let's look at these last two. X to the 5th minus x cubed plus x. X to the 4th plus 3x plus 2. So x equals 2, we have 2 to the 5th minus 2 to the 3rd plus 2. Negative 2 to the 5th minus negative 2 to the 3rd plus negative 2. Two to the 5th, 2, 4, 8, 16 is 32. 2 to the 3rd is 8 plus 2. 32 minus 8 is 24. It's 26. Negative 2 to the 5th can be negative. 2 to the 5th is 32. Negative 2 cubed is negative 8, so it's minus negative 8. Plus or minus is a minus, so that's going to be a plus. Negative 32 plus is negative. 32 minus 8 is 24. Plus 2 is 26. So what does that tell us?
Odd number? It's an odd.
It's an odd number. Very good. Yes, because you have the same number, 26. One's positive, one's negative, so it's odd. And then the last one. Fourth. Two to the 4th, 2, 4, 8, 16. 2 squared is 4. 3 times 4 is 12. 28, 30. So this is negative 2 to the 4th, so it should be positive 16. Negative 2 squared is positive 4. 16 plus 12 plus 12 is 30.
Even. Yeah.
Okay, now why did I go through those 8 different types of problems? I did that to give you all a shortcut. Let's look at these. We know if the only thing is an even exponent, it's even. If it's an odd exponent, it's odd. If it's a constant, it's also even because it never changes. So out of these first three, which ones can go together?
The first and the third.
Yeah. So if your equation has only even exponents, then it's even. If your equation has only odd exponents, then it's odd. If your equation has even and constants, then it's even. But if it has an odd exponent and a constant, it is neither. In other words, the only people that could pair up with the constant are the evens. And that's what we did here in the next one. X squared, that's an even with a constant, so it's an even.
Right.
The next one, x cubed, that's odd. Odd and even doesn't match, so it's neither.
Wow.
You can't have them mixed, odd and even, neither. These are all odd. What's this power?
To the
One.
one.
Yeah, so it's 5, 3, 1. Those are all odd exponents, so they're all odd. All even and a
Mhm.
constant, it's gonna be even.
Even.
So that's shortcut you could do for it.
That's amazing.
I know.
It'll save you from doing the work. Okay, let's go ahead and do the last thing of the chapter. Transformations. Now the transformations, you have to know the original, you have to know the library of functions. For example, every equation is going to have this configuration. I'll call this G. What we're going to be looking at these four letters, A, B, C, and D, and see what they do. Let's look at the first one. Let's look at horizontal shifts. In other words, that's either left or right shift. Here's our first example. What you have to do is you have to break it down to its original. So here are the steps. Find the function in the library of functions. So what function would this match to in the library of functions? The easiest way to do that, because in the library of functions, we have X and everything else around it. So that +3, if we get rid of the +3, what do we have left?
X.
X squared. Because here's the X and there's a square. So if I get rid of that 3, I have just a function X squared. We know what that graph looks like. That's the parabola. The U-shaped thing.
Can I ask how you know?
It's the graph or
Yes, for the graph. How do you know that's how?
that's what we did. Look at when I did all those pictures earlier.
Okay.
Let me look right here. When we did quadratic equations, if it's x squared, then it has that shape.
Oh, okay. Okay. Thank you.
Yes. And again, like we just talked about, since it has a power 2, and here's the x inside the parentheses, that means we're going to have at most two solutions. And the only one that has 2 solutions is the U shape. Now, the second step, set inside parentheses equal to 0 and solve. So we have x plus 3 equals 0. Subtract 3. X equals -3. That is your horizontal shift. What we're doing in these transformations, all we're doing is we're finding a new place for the origin. So here's the origin. Since we found this in our second step, in other words, this is my new origin. So it means the graph shifted 3 spaces to the left. Since it happened inside the parentheses, that's a horizontal shift. Inside the function, I should say. The function is x squared. I changed the x first before I squared it, so it's a horizontal shift. Let's look at another one. So what's the function from the library? If you get rid of the number, what do you have left?
Absolute value?
The absolute value of x, right?
Yes.
The function is the absolute value. So now here, x is being changed. So that means it's a horizontal shift. Set inside the operation equal to 0 and solve for x. This is your horizontal shift. So the original graph was like this. That's that one. This one says, I now have to move the origin to 2. So from here, I got to bounce it to 2. The graph remains the same. There's a new graph. So if it happens inside the operation, the absolute values, the square root, or anything else, then it's a horizontal shift. So what's the original function?
The cube root.
The cube root of x. Very good. And what does that graph look like?
Actually curved.
Yeah, it's like a sideward side S, like a
Mhm.
snake. Solve inside the operation. So that means now my new origin is at -2. So there's my new origin. The graph looks the same. It's just that only thing changed is the origin. It's like you cut and paste this picture and moved it two to the left. Remember when we did circles and we looked for the HK values for the center? Same thing here. If you look at all these, if it's x plus 3, take the opposite sign, the answer is -3. That's the shift. If it's x minus 2, opposite sign, the answer is +2. So I shifted to the right 2 spaces. The last one, x plus 2, opposite is -2, so I shift to the left. So you could use that shortcut if you want to, or you could set it equals 0, but it's a lot easier if you do it that way. So that's a horizontal shift. It happens inside the function. Next, we have a vertical shift. Vertical shifts happen outside the function. If it's positive, it goes up. If it's negative, it goes down. D units. How about that? What's the original function? X squared. That's just the x part. So we know that since it's x squared from our library function is that. Is there a horizontal shift? No. Is there anything affecting the x first before you square it? No. So now we look at the vertical shift. -3. So that means the entire graph goes down to -3. How about that one? 1 over x squared plus 2.
Oh. I always hated these.
Yeah, again, it's the fractions, so we use a lot of these. Is there a horizontal shift? No, do you see x is inside a parenthesis or anything that has a plus or minus after it? No, so there's no horizontal shift. This is outside the function. The function is right here. This is outside, so it's a vertical shift. So what does 1 over x squared look like? Because that it can't be negative. So it's the Atari symbol. And then whatever that graph is, it goes up 2 spaces. So there's my new origin. It shifted up 2 spaces. The graph looks the same. So far, so good? Okay, let's do one where we combine all this stuff. And then we'll start looking at reflections.
It's gonna be the rational one.
Yes, what's that going to look like? So it's 1
at the
over x.
bottom and one at the top.
Yes, 1 on the bottom, 1 on the top. So the second step is your horizontal shift. Since x has a +2 next to it, we already know it's going to be -2, but let's work it out. Because it's opposite signs. So it shifts left 2 spaces. So there's that graph, there's that graph. And then lastly, we have a vertical shift. We have 1 over x +2 minus 3. So we went over 2. Now we have to go down 3. So we're over 2 for that one, down 3. So here's our new origin. The graph looks the same. Does it make sense? If we do it in pieces, you shouldn't get messed up. Reflections. Because up until now, we've only looked at C and D. If it's inside the function, it's a horizontal shift. If it's outside, it's a vertical shift. That's all we've done so far. Now, for reflections, we're going to look at the coefficient out in front, the leading coefficient. We have 2 types. We have a vertical reflection. We'll make it upside down. How do we make it go up vertically shift? If we put the negative in front of the function. In other words, if your leading coefficient, if A is less than 0, the graph flips across the x-axis. So if our leading coefficient is negative, then we know it flips across the x-axis. So the original function we have here is x squared. What that means now is any x that we have, or any answer that we have, we simply change its sign. Now it goes down. Negative coefficient makes it go down, positive makes it go up. So there's your graph. Let's look at that.
It's looking upside down and now it's gonna look upside up.
Well, first off, what's the original function?
It's absolute cube. Wait, what's it called? Absolute
Absolute value of x.
absolute value of x. Yes.
Okay, so, and that graph is at v. Then we do inside the function. So what kind of shift happens inside the function?
You do a positive instead of
Horizontal
negative.
shift? Well, no, it's an x plus
Oh,
3.
wait, so
So,
it's negative.
yeah, so it's a
Wait.
horizontal shift. So we have to shift it to the left 3 spaces. So there's my new origin. Now with a function, now we have to change directions. Instead of pointing up, the function now points down. 2, 3. Because that's what that negative tells me in front. What's the last thing I gotta do? We've done inside, we've done outside. We haven't done the -2 part yet. So So what does that -2 tell me to do? Since it's a -2, I go down 2 spaces. So my new origin is right there, and there's my graph. So inside here tells me go back 3 spaces and down 2, and then flip it. So far, so good. So if it's outside the function, then it's a flip across the x-axis. If it's inside the function, you flip across the y-axis. If it's outside, you flip across the x-axis. You go up and down. So if the negative is outside the function, flip across the x-axis. If the negative is inside the function, flip across the y-axis. When I say negative, I mean, if it's inside, it has to be in front of the x. If it's outside, it's outside the entire function. But if it's inside, it has to be in front of the x. So the original function here is the square root of x. The graph from your library chart is that. Now think of this. You cannot have negatives inside square roots, right? So what does x have to be to get rid of that negative? X has to be negative. A negative times a negative becomes a positive. So that's how come it now flips direction. I can only use negative x's. So that's what I'm saying is that's what flip across the y-axis means. There. -1 over 2 minus x squared plus 1. What's the basic function?
Rational square.
Yep, rational squared, because x is on the bottom, so it's 1 over x, and it's squared. Very good. And that looks like the Atari symbol. Because you can't have negative answers. What's the horizontal shift? Take what's inside the function, set it equal to 0. So I add x to both sides. So x equals 2. So it shifts to the right 2 spaces. What's the next shift I gotta do?
The +1 in the y-axis.
Nope. What about the numerator? It
The-
has a negative.
Oh,
The numerator has a negative.
-1.
And what does that tell me to do? Since it's negative in front, remember, if it's on top, it could be out in front. It tells me I have to flip my graph across the x-axis. If the negative is outside, flip across the x-axis. This negative is outside that, so I flip across the x-axis. Inside here's my horizontal shift. This negative tells me to flip across the x-axis. Now my last step tells me to go up one space. So here's my new origin. It's now at. So the graph looks like this. What do y'all think? Each step is you have to look at it separately. Do it piece by piece by piece. First off, you have to determine what is the function you're dealing with. Find where the x is, and is there any parentheses? Are there any parentheses around it, or brackets or anything? That tells you the function. If x is on the bottom, it's automatically 1 over x. There's a squared. That's the graph. Then we got to look at what happens to x. 2 minus x, set that equals 0. That's your horizontal shift. So that's 2. Then, right now we're looking for positive or negative with respect to the function. Since it's negative up top here, the whole thing's negative, because negative 1 over x squared is the same thing as negative 1 over x squared. So that means because it's negative, I got to flip it over. And then I can look at the vertical shift. Goes up 1. Let's do one more, and then we'll finish up this chapter on next time, because we're getting close to being time to go. Now, because the last 2 sections are with horizontal and vertical shrinks and stretches. Those are 4 rules in themselves that are pretty complicated. So I want to make sure we have lots of time that we'll do that, and then we'll start chapter 3 next time. Okay. There. Yeah, I added an attachment. There's another one. Negative cube root of 1 plus x plus 2.
So it's cube root rational.
Radical.
Radical.
Yeah, rational is fraction. So yes, it's a cube root of x. What does cube root of x look like? That's like a snaky S. All right, what's the horizontal shift tell me to do? Do I have a horizontal shift? Well, yeah, here's the function. Take what's inside there and set it equal to 0.
We'll stay -1, yeah.
-1, right? So that means we're going to shift to the left 1 unit. The graph still looks the same. It's just shifted to the left 1 unit. What's next? On our decomposition of the function,
The +2.
nope, we have a negative.
Oh.
We can't do +2 until we finish everything on that function.
Oh,
So we have a radical negative in front of the radical 3. Since it's negative, that means I flip across the x-axis. This side goes down, this side goes up. Like that now. This side goes up, this side goes down. Now, the last step. That's why I could do +2. That means go up 2 spaces. So there's my new X and Y origin. It goes this way. And there's my graph. Do it in pieces. You shouldn't have any trouble with it. Okie doke. All right, and then we'll finish up this chapter next week and start chapter 3. Because the sooner we can get to chapter 4, that's the meat of the course. Then we can spend more time because that's where the most moving parts are. Because yeah, no matter how much, that's why we have chapter 7 and 8. Those are our buffer chapters. If we have time, we'll do them. If not, then we won't do them. But definitely we have to go through chapter 6. So whatever time we have left. Okay, everybody.
Thank
That's it.
you.
Thank you all very much for coming to class today.
thank you, Professor. Have a good
Have a
day.
great
Yeah, oh, I'm
weekend.
sorry. I'm sorry about last week when somebody was talking and the machine died.
Yeah, that's
right when
fine.
you were saying- No, it's because my battery was going dead. And all of a sudden-
We kind
I'm
of knew
so
because
sorry.
you let us know before ahead of time. You
Yes.
were like, it's gonna
Yeah,
die.
my mouth dropped. Uh-oh.
That's okay.
All right, y'all have a great week.
Thank
You
you.
too.
Thank you.
Bye-bye.
Bye-bye.
Bye-bye.